Good day to all. Today we are going to see about that static resistance control, static rotor resistance control. You will see here there are star connected rotor winding is there. Here is one coil and here is one coil, here is one coil. These are all connected with that slip ring with the brushes and the external star connected yourself to over here. And this is the star shaft and this is the brush. See, the slip ring motor or phase wound motor is an induction motor which can be started with full line voltage, then applied across its stator terminals. The value of starting current is adjusted by adding up to external resistance to its rotor circuit. So the thing is, here the phase wound motor is an induction motor which can be started with full line voltage and this applied across its stator terminals. The value of starting current is adjusted by adding the external resistance to the rotor circuit. See, this is the graph of that static stator control method. You will have a current and a rotor speed like that. We will have a current. This is the full voltage stator current. It has a slight decrease over there. Then it will have a sudden decrease. Likewise, full voltage torque. It has a sudden increase. Then it will have a peak increase. Then it will have a decrease over here. Then it will have that FLT value over there also. So the main advantages and disadvantages of these AC drives are for the same rating and the AC drives are lighter in weight as compared to DC drives. So the thing is, same rating AC drives are lighter in weight as compared to DC drives. See, this AC drives has a lighter weight compared to DC. It has a less weight over here. But in DC that will be more weight. The rating is the same position. For AC drives require low maintenance. It will require only low maintenance, whereas if we are going for that DC machine, we will have their huge maintenance or more maintenance needed over there. Then these AC drives are less expensive. It is not more costly compared to other drives. It has a less expensive. That is one of the most useful advantages in that industry itself. Then it provides the most efficient means of motor speed control. So the thing is, we can say nearer to approximately we have a control of the speed of the motor. That's why we denoted here as it provides a most efficient means of motor control. More efficient means we will have a more accurate, or we can say nearer to the accurate of that control. We can have that near the accurate of the control in that speed control method. Then we'll reduce the thermal and mechanical stress on the motor. See, when the motor is running, there is some thermal stress is produced over that motors, as well as that mechanical stress also will produce, because if that any motor is run automatically heat will produce. Then the thermal, which means that heat, as well as the mechanical stress will also produce over there. These two will reduce in that AC machines compared to other drives. In the AC drives, it will reduce. Then provides a low speed motor starting facility. It will have a provide a low speed motor at the starting facility. Then save more energy. We can save more energy over here. Then power converters for the control of AC motors are more complex. It is also one of the main advantages. Here, the saves the motor's energy. More energy means we will have a less consumption of that power. See, nowadays, cost-wise, if you are seeing going for that industry, there are various applications. There are more number of motors used over there. If it has take more energy or more power, that will also affect in the cost-wise. So, if it is saves more energy, that will very much advantages according to that industry purpose. Same wise, power converters for the control of AC motors are more complex. The main thing is here the power converters we are using for this more AC motors. Sometimes we need to use the power converters for that controlling the AC motors. So those are more complex. That is not very easy to do that. That will be the more complex one. And the power converter for that AC drives are also more expensive. These are all a disadvantage of this AC motors, because we want to use this power converters. If you are going for use the power converters, that will have a more expensive. The rate is high in the market. Then the power converters for AC drives generate harmonics in the supply system and the load circuit. See, this power converters for AC drives generate the harmonics in the supply, which is also having disadvantage over that these AC drives. Now we will see the industry application where we will use that motors. See, this induction motor with squirrel cage are the workhorse of that industry. When squirrel cage induction machines is operated directly from the line voltages, and induction motor is operated at a constant speed. However, in the industry, we require to vary the speed of an induction motor. This can be done by an induction motor drive. So, the fans, compressors, pumps, blowers, and machine tools like lathe and drilling machines, lifts, conveyor belts, etc. For that, fans and compressors and pumps, blowers, these are all the things will have a continuous running of that in that industry. Drilling machines, lifts, and conveyor belts are also have a continuous rotating applications, which means the motor should operate continuously without rest, and we can say less time of rest. So it will need a more efficiency also when we are going for that industry. This is the induction motor in lube oil system of steam turbine. In that steam turbine industry, the induction motor will use over here. Then this is the picture of the coal feeder industry. Here the induction motor will be used over here. That's all. Thank you.